Okay, so we're looking at the Math 200. This is the final review. We're doing problems 11 through 20. And so before I start, my other class said, hey, you had C3PO as your TA this whole time of doing the video, so let's hear some trivia. So here's the last bit of Star Wars trivia. The Stormtrooper, they're the bad guys. They had this little tube on the back of their belt because in the original design and his original concept of the movie, he was going to have everybody carry around lightsabers. And so the tube and the lightsaber design was always, it's just the hilt, and then that's not, it's not supposed to be a tube like this if you haven't seen the movies. It's just the base here that you carry on your belt, but then when you turn it on, like a plasma or laser, whatever, that ends at 3.5 feet, comes out and you can cut through stuff and fight bad guys. So he changed the design though. He decided that everybody wouldn't carry it. He kind of borrowed from King Arthur, the story of King Arthur, the sword of power. Knights, they were called Jedi Knights, right? So the little King Arthur thing there. So that was a change that they made in the script, but they didn't change the costume. So now you know some useless Star Wars trivia. All right, so let's go into math. Divide. We never divide fractions. We multiply by the reciprocal. And so, wait, before I flip that one around, let's factor this. So it multiplies to be 21. That adds up to be 10, right? 21, not a lot of suspects. 1 and 21 or 3 and 7. That's got to be the 3 and 7. And we had a little hint up there, right? X plus 3, X plus 7. So now we're going to do times, but now this X plus 7 is going to go on top. X minus 5 on top. So those are up. This is down. Oh, let's factor out, what can we factor out of that? An X. And then divide that by X, X plus 3. So there we are. We're all factored. And now let's cancel. So here, I'll make like this saber sound. Dun, 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 dun. And I think that's it. So that's all that can be canceled. So on the top, we have X minus 3, X minus 5. On the bottom, we have X and X plus 3. That's it. Don't multiply it back in. Just leave it all factored. We're good. Leave it all factored. So factor and cancel is the name of the game on that one. And also remember, divide, we multiply by the reciprocal. Okay. This is definitely an ugly problem. We have to find a common denominator, and it's a binomial. And so the common denominator, the LCD for this, is X minus 3X plus 3. Gil. So that means I have to multiply this one by X minus 3 to get that common denominator. And you got to do the same thing, top and bottom, right? Numerator, denominator. And so this one needs an X plus 3. I got to do that on the top. So now we're going back to like chapter 4, I think it was, where you had to do multiplication, right? So distributive property choice or FOIL, X squared plus 3X, and then the minus 4 gets to turn, minus 4X, minus 12. That's over X minus 3, X plus 3. And then it's minus, oh, they made this even tougher. So we got X minus 3X plus 3 again on the bottom. The denominator, that's the common denominator. But when we do this, we get X squared minus 3X plus 1X minus 3. Okay, so we can combine up like terms. That's X squared minus 1X minus 12 over X minus 3X plus 3. And it's still minus X minus 3X plus 3 on the bottom. And X squared minus 2X minus 3. But we're still not done. I'm going to write it all the way up at the top of the board here. all under the same roof here. X minus 3, x plus 3 is the denominator. This is the first part, x squared minus 1x minus 12, but now it's minus all of this. So we're going to do the distributive property on that negative. So we have this, x squared minus 1x minus 12 minus 1x squared plus 2x plus 3. That changed the sign of everything inside the parentheses, that minus sign. X minus 3, x plus 3. So you're really earning your points on that one. It's really tedious. And now we combine like terms. So this x squared and that x squared cancel each other out. We got negative 1 and positive 2, so that's just x. We have negative 12 and positive 3, that's negative 9. All over x minus 3, x plus 3. And that's it. We're done. But, whew, that was a lot of work. All right. So, fortunately, now it gets to be quick problems. So, let's do those quickies. Radicals. These are fast. 13 is 25 to the negative 3/2 power. So what that means is 1 over 25 to the 3/2 power. And again, if you want to do it without your calculator, you could do this one as the square root. That's the 2 part. And then of 25. And then whatever you get, take that cubed. So what is the square root of 25 is 5 cubed. That's 1 over 125. If you wanted to, you could, instead, I'd still write it upside down, like, move it down. The negative exponent moves it to the bottom. But you could type it into your calculator, like so. Do the little power thing, do a parenthesis, 3 divided by 2, or just put in 1.5, 25 to the 1.5, and it'll just kick out 125 for you. So we could do that as a calculator problem if you'd like. All right. All right, 14, we got the square root of 75 minus the square root of 147. Whew. Okay, so 75, we know that's 25 is perfect, 3 is a leftover. And so we get 5 square roots of 3 on that. I would say if this happens where you get a weird number like this, try 3, divide that by 3. And when you do divide that by 3, 147 divided by 3 is 49, which happens to also be a perfect square, right? Perfects and leftovers. So 7 square roots of 3, 5 square roots of 3 minus 7 square roots of 3, negative 2 square roots of 3. Okay. So there is another way to do that. If you want to break it down into 3 times 5, it's 5 minus the square root of, and now 147, you still have to know probably it's divisible by 3. Remember the trick, 1 plus 4 plus 7, that's 12. 12 is divisible by 3. When you add up all the digits of any number, if you get a number divisible by 3, the original number is divisible by 3. So we know that was divisible by 3. You'd see 3 times 49 and then say 3 times 7 times 7. And now with the prison break style or the prime factorization method, you look for groups of 2 with square roots. And only one lives, and then that one's stuck. Groups of 2, but only one lives, that one's stuck. And we get the same thing. So, all right. 16, much easier than that. Square root of 4x plus 5 minus 7 on the outside equals 0. So right now it doesn't look easier, but it's going to become easier fast. So this is not an expression. We don't, we just, look, it's equals. So it's an equation. So that means we rule the universe with the equation. So we square both sides. That'll liberate the 4x plus 5 out of the square root sign. So we'll have 4x plus 5 equals 49. And now we're back to week 1, solving two-step equations. So minus 5, we get 4x is equal to 44, and divide by 4, x is equal to 11. And whenever you square both sides, you should pop that back in and make sure it works. 11 times 4 is 44, plus 5 is 49. Square root of 49 is 7. 7 minus 7 is 0. So it works. All right. Let's look at 17. I do miss all of your smiling faces. I really miss that. I hope everybody's at home and safe, and I hope you still are learning this math. And hopefully you'll use it someday on something. All right. So imaginaries are complex numbers. So the way we attack these are, if we want to rationalize, we're worried about the denominator. Divide. So we don't want imaginaries in the denominator. No complex numbers in the denominator. So we multiply top and bottom by its conjugate. 3 minus I. So not the exact same thing. The minus instead of the plus. That's called its conjugate. So it's not opposite either. Opposite would be negative 3 minus I. It's a conjugate, so because we only change one sign. Now, on the top, we're going to just leave that. 2 times 3 minus I, because that 2 might cancel with what we get here. Here, we're going to do the distributive property twice, or FOIL, whichever way you like to look at it. 9 minus 3I plus 3I minus I squared. And so now, remember, I squared, it's a complex number, is negative 1. So this is minus negative 1 right there. Those cancel. So we end up with 2 times 3 minus I over 9 plus 1. Well, that's 2, 3 minus I over 10. And we can, in fact, reduce that, right? We can divide top by 2 and bottom by 2. Like, reduce the numbers. And so we get 3 minus I on top and 5 on the bottom. And we're good. If you want, I don't care. If you're doing the online, they wouldn't let you leave this answer like this. They made you go 3/5 minus I fifths. So it looks like the A plus BI. I don't care. You can leave it like this if you want. You can leave it like this if you want. Either way, it's fine. All right. Okay. 18, 19, and 20. So 2 to the negative x is equal to 1/16. That's 2 to the negative x is equal to 1 over 2 to the 4th power, right? So I did this differently on the notes. I think I'm going to do it differently here for you on the board a little bit. On the notes, I took this up and made it -4 and then said negative x is equal to -4. On here, I think because it's a negative exponent, let's ship it down. Let's go to the bottom. So we have 1 over 2 to the x is equal to 1 over 2 to the 4th. And now look, the only way that these could be equal, is if this was the same as that. So we just say x is equal to 4. I actually think that's an easier way. I did it on the notes. I moved that up and made it 2 to the -4 and then said negative x equals -4 and divide by -1. I still got 4, but I think it's easier to look at like that. So maybe do it that way. All right. Let's get 19 and 20. And then we're done with notes forever in algebra. So here goes. We've got 19 is log base 3 of 1/27 equals x. So there are 2 ways to do it. You could do it on your calculator, but I'd rather you didn't do it on your calculator. Let's write this out. Remember, logs are just a fancy way of writing an exponent. So look, log base 10 of 100 is equal to 2. What this is asking, when you have log base of this number, it's saying, what do I take this number to what power to get that number? That's all this is. Logs are just a fancy way of writing an exponent. So 2 squared is equal to 100. So if you can remember this basic framework, log base 10 of 100 is equal to 2, and then write it without a log, that's 10. If you have 10 and 2 and 100 and you have to write it as an exponent, it would be 10 squared equals 100. And so now you know where all the pieces kind of fit. So what does that mean for this? That means that 3, right, that's in this position, is the base. And then 2 came over, so that's to the x power is equal to over 27. And so this is very similar to number 18. 3 to the x is equal to 1 over 3 to the third, right? 27 is 3 to the third power. And so now let's do what I did on the other one to work it out on paper. Let's ship that up, but then we're going to have to throw a negative on it. Normally it's negative, we ship it down, that's the price of shipping. But now look, we have the same base. I have 3 to the x and 3 to the negative 3, so x is equal to negative 3. Now, I did mention you could do this on your calculator. It is workable on the calculator. You could, now your calculator doesn't have probably base 3. It's got base 10 or base e. That's the natural log, ln. What you would do to type that in your calculator, you would want to go log base 3 of 127. So we're trying to do this. So you don't have base 3, so you'd have to do the change of base formula. That's log base 10 of the number on top over log base 10 of the base that you want. And that's called the change of base formula. So on keying it in, it would look like this. log of parenthesis will pop up. You do 1 divided by 27. And then you have to make sure to hit that end parenthesis. So many students forget that. And then divide by again. And then log of 3. And then hit enter. And so if you type that in and then hit enter, it will be negative 3. So that's how to do it on the calculator. I don't know. It's almost more confusing to do it on the calculator and just write it out like that. Let's look at 20. We have log base b of 4 plus log base b of 3 minus log base b of 6. So remember, I told you that logs are just a fancy way of writing exponents. So if you remember from back in the day when we had x to the 7th times x to the 3rd, when you were multiplying things with like bases, you added the exponents. And so that was x to the 10th. And dividing, if you had x to the 15th over x to the 7th, you would say x to the 15 minus 7. When you divided, you subtracted exponents. Divided like bases, subtract the exponents, that would be x to the 8th. So logs are just a fancy way of writing exponents. So guess what? Plus in log land means multiply, and minus in log land means divide. So if I say I want to write this all under one roof, log base b, because look, it's all log base b, log base b, log base b. I can say 4 times 3 divided by 6. And that's all under that same log now. Log base b of 12 over 6. That would be, my final answer would be log base b of 2. All right. I did a video for each one of the chapter 9 notes too, where this is a little more in depth, explained in depth. All right. So that is what your final is going to look like. Oh, the Stormtrooper reference. Look. I'm even wearing the shirt. I mean, underneath my blue shirt. It's the Stormtrooper writing on the board 100 times. Those were the droids we're looking for, seeing they have C-3PO and R2-D2, and that was why I gave you Stormtrooper trivia. So I hope you ace the test, study, ace, and have a good summer.